So hello everyone, we are back again with part 22 of the chapter Light, Reflection and Refraction. And today's video is going to be very important because today we'll talk about sign conventions for spherical lenses, and these sign conventions are very important to be understood for the purpose of solving numericals. So let's begin. Before we go ahead with the sign convention for spherical lenses, I would advise you to also visit uh, in one of our previous video where we have discussed about sign conventions for spherical mirrors, because the sign convention for mirrors and lenses are exactly same. Only difference is the in place of mirrors we have lenses here, and in place of pole we have mention of optical center, and the terms like in place of twice of focal length, as in center of curvature for mirror we have twice of focal length. And yes, definitely we have focuses on the uh, either end of the lens. So let's begin with the sign convention. So if you all recollect from the understanding of the graph, so it goes exactly the same way. So if you observe in graph, we have y-axis and we have x-axis, and all the measurement on this side is taken as positive, this side are taken as positive, positive, negative. So you can see this is how we go in the graph, and here also we are going in the same manner. These are negative, these are also negative, these are negative, and these are positive values. So similar way you can understand here that all the measurement for this system, they starts from the center, and the center of the lens is called as optical center, whether it's a concave lens or convex lens. All the measurement towards the left side, which means towards the in the direction opposite to the direction of light ray, are taken as negative. All the measurement in the direction of light ray, which means on the right side, are taken as positive. All the measurements above the principal axis are taken as positive. All the measurement below the principal axis are taken as negative. And we will always keep the object on the left side. Now again, even if we keep the object on the right side, the rules are still valid, because if you keep the object on the right side, then the light will come from the right end, and the rules will just the direction gets reversed. Only difference is going to be, we will not say left and right, then we will have to mention that all the distances in the direction of light ray will be taken as positive, against the direction of light ray will be taken as negative. Above principal axis is always positive, and below principal axis is negative. So let's see the statements for the sign convention. If you have understood everything related to the mirror, then this should be very easy for you to understand. As we discussed, all the distances are measured from the optical center of the lens. So we'll start all measurement from the center. The distances measured in the same direction of incident light are taken as positive, which means usually we say we keep the object on the left side. So if it is in the same direction, it means if you're going on the right side, all the measurement will be taken as positive. You can see here. And next one, the distances measured against the direction of incident light are taken as negative. So if we are keeping object on the left side, light is going in the from left to right, then if we are measuring object distance, it's going to be negative. So all the distances on the left side are taken as negative. Next one, distances measured upward, we will always keep the object above principal axis. So height of object will always be positive. So distances measured upward will be above the principal axis will always be positive, and below the principal axis will always be negative. So based on these sign convention, there are some conclusions. Let's try and understand those conclusions. First will be, you can see we will always keep the object on the left side. So object distance is always going to be negative. Image distance could become negative or positive based on whether we get the real image or virtual image. So let's see the conclusion. These are some of the conclusions on the screen. These I would advise you to make a note of all of them for the purpose of solving numerical. So first one, u is object distance, which will always be negative because always object will be kept on the left side. V can be positive and negative both. It is positive for real images because real image in the case of lenses will be formed on this end, which is on the right side. So V is positive for real images. V is basically image distance. V is going to be negative for virtual images because virtual images will be formed on this side. So going ahead, H1, which is height of object, will always be positive because object will always be kept above principal axis. H2 or height of image will be positive if it's a virtual image, because virtual image will be images will be erect and Erect means we are going above principal axis, so it's going to be positive. And for real images, not on the side, real images, it's always going to be negative. Now, this is important point. Focus for convex lens, because the focus is attained here. You can see converging lens, focus is on the right side. So focus or focal length is going to be positive for convex lens, and negative because for concave lens it's going to be on the left side, so it is going to be negative for concave lens. Magnification is depending on where the image is formed, so it is going to be negative for real and inverted image, because we'll talk about what is the formula for magnification. We'll talk about these points. We'll again talk after we are done with the formulas in the next video. So magnification is negative for real and inverted images, positive for virtual and erect images. It is always going to be greater than 1 for magnified images, less than 1 for diminished images, and 1 equal to 1 when they are of the same size. When I say greater or less than 1, that does not mean that if you get magnification m equals to -3, this does not mean that it is less than 1. This means it is greater than 1 because the number, and negative sign indicate that its direction, whether it's formed upward or downward, whether it's real or virtual, that we'll discuss based on the formula. So these were some of the sign convention which you have to keep it in mind for solving numerical, and we have covered the sign convention. Now in the next video we'll talk about what is the lens formula and what is the formula for magnification for spherical lenses. That's it from my end. Thank you and have a great day. Bye bye.